So let's go to the next part of exponential equations. In this case, we will be solving exponential equations with different bases. So one of the rules is this: get the logarithm to any base of both sides. Let's go to the first example. 3 to the x is equal to 5. The bases are not the same. Therefore, we cannot equate the exponents. So what we do here is either we take the log of both sides, say take the log base 3 of both sides. So in this case, logarithm of 3 raised to x base 3 is equal to logarithm of 5 base 3. So whatever base you apply to the left, you should also apply to the right. And then take note that since the argument and the bases are the same, that cancels out. And then the 3, one of the properties of log, the log of a power, this goes down in front as x. So this is an answer. However, what if you chose 5 as your base and not 3? What you can do here is logarithm of 3 raised to x base 5 is equal to logarithm of 5 base 5. You know that since the argument and the base are the same, that's equal to 1. And then to solve for x, isolate it, divide everything by logarithm of 3 base 5. So this is also an answer. And then if you check this in your calculators, they should give you the same final answer. Now, another technique is, this is what I usually use. What I do is I apply base 10 because it's easy for me to just apply base 10, and then afterwards I can just choose to change the base. So in this case, if I apply base 10 to both sides, that's logarithm of 3 raised to x is equal to log 5. The x goes down to the front, and then I isolate x, I divide everything by logarithm of 3. So the answer could be logarithm of 5 over logarithm of 3. And then if you can recall one of our rules or one of our laws of logarithms, I can say that this is basically logarithm of 5 base 3, which is actually the answer here, the first answer. This is again change of base. But you can keep it like this, like the first one. And then you can also apply ln if you want to. So ln of 3 raised to x is equal to ln of 5. Again, ln is logarithm base e. X goes down to the front and then divide both sides. So here you have ln of 5 over ln of 3, which is actually the same as logarithm of 5 base 3. Another example, in this case, both sides have x's. What do we do? Either we choose base 4, so the left side would cancel out, that becomes 1, or choose base 7 so that the right side cancels out, or I choose base 10. I keep both arguments. So in this case, if I apply base 4, the exponent or the power goes down to the front. And then logarithm of 4 base 4, that's equal to 1. You're left with 2x minus 1 is equal to logarithm of 7 raised to x base 4. The x goes down to the front. You're left with logarithm of 7 base 4. Now, since you're solving for x, all x's have to be on one side. So 2x minus 1 is equal to x logarithm of 7 base 4. So transpose this to the other side. And then the 1 there, the negative 1, transpose to the other side. And then factor out x. You're left with 2 minus logarithm of 7 base 4 is equal to 1. And then just divide that. I would have this as an answer. Another solution, what if I use base 10 or base 7? In this case, base 10 was used. So if it's base 10, the power goes down to the front, and this one, the power also goes down to the front. And then the left side, if it's on the left side of logarithm, you can distribute. But for the arguments, you cannot distribute. So in this case, just distribute that. 2x logarithm of 4 minus logarithm of 4 is equal to x logarithm of 7. Since I'm solving for x, we have to combine both x's on one side. Those that don't contain x, you move it to the other side. That's why you have this line. 2x log 4 minus x log 7 is equal to logarithm of 4. And then I factor out x. I'm left with 2 log 4 minus log 7. So dividing everything by that term, it goes to the denominator. So this answer here, if you check that with the answer here, they should give you the same final answer if you input that in your calculators. In this case, where the base is e, some people would just use ln. Like for me personally, I would just use ln to cancel out the e. And then I solve for x. So in this case, ln was used on both sides. So 3x plus 2 goes down to the front here. And then ln of e is equal to ln of x. Take note that ln e is equal to 1. So you're left with 3x plus 2 is equal to ln of 8. 2 goes to the other side. So it can be ln of 8 minus 2 all over 3. But also, you can use base 10 log or base 8 log. It depends on what you really use. So let's try. In order to solve this one, what I would do is I'd remove first those terms that don't contain x. So in this case, 3 raised to x is equal to 4 plus 1, that's equal to 5. Since the bases are not the same, I can choose to have change of transformation. I can just transform. Remember transformation? So my final answer could be logarithm of 5 base 3 is equal to x. So this is an answer. However, if for example you want to use some of the techniques that I have shown you earlier, if I apply logarithm 3x is equal to logarithm of 5, so this is another technique. So let's just say method A, this is method B. So here, the x goes down to the front, leaving me with x logarithm of 3 is logarithm of 5, and then divide both by log 3. I'm left with log 5 divided by log 3, or this is actually change of base. That is logarithm of 5 base 3. So that is an answer. Now let's try this one, the next one. 5 raised to x minus 1, and then I transpose. So I don't have any other option because both have exponents x. So I can choose to use logarithm base 10. So I can say logarithm of 5 raised to x minus 1 is logarithm of 2 raised to x. So x minus 1 logarithm of 5 is x logarithm of 2. And then distributing this one would give me x log 5 minus log 5 is equal to x log 2. And then let's combine those terms that contain x. X log 5 minus x log 2 is equal to transpose those that don't contain x. It's simply log 5. If I factor out x, I'm left with log 5 all over log 5 minus log 2. Okay? But some people would write it as log of 5 over 5 halves. That's also acceptable. Because at the bottom, you can apply the properties of log. And then after that, you can apply change of base. But the first one is good for me. Let's try this. This has 3 times 2 raised to x. So let's combine those first that don't have powers. So this is 15. 13 plus 2. And then I divide everything by 3. So 15 divided by 3 is 5. So this one's easy. I can just say, if you want, you can apply base 2 log. Let's try. Logarithm base 2 to x is logarithm base 2 of 5. So here, x times 1 is equal to logarithm of 5 base 2, or simply, let's just rewrite that. It's this one. Or from here, from this step, you can actually just transform it. Transform from exponential to logarithmic. It would give you the same answer. Here, 2 to the third, 2 over 3, sorry, x is equal to 5 raised to 3 minus x. So what I can do here is I apply log to both sides. Maybe I can just apply base 10. X is equal to logarithm of 5, 3 minus x. So x log of 2/3 is equal to 3 minus x log of 5. So let's combine those with x's. X log of 2/3 plus x log of 5. You're left here on the other side with 3 log of 5. Therefore, x is log of 3 log of 5 all over log of 2/3 plus log of 5. You can actually combine this. That becomes 10/3. And then you can simplify. But this one is acceptable. Let's try more. So here, if I want to use base 3, logarithm base 3 of 5 raised to x minus 3, logarithm base 3 of 3 2x minus plus 1, this becomes 2x plus 1 multiplied by 1. This is x minus 3 logarithm of 5 base 3. So let's distribute x logarithm of 5 base 3 minus 3 logarithm of 5 base 3 is equal to 2x plus 1. I combine all those with x. I can say x logarithm of 5 base 3 minus 2x is equal to 1 plus 3 logarithm of 5 base 3. So factoring out x, 1 plus 3 log of 5 base 3 all over log of 5 base 3 minus 2. Let's go to the last example. Here, if you want to retain the 8 as is or you want to make it prime, it's up to you. So if I want to make it prime, so 2 raised to the third power, 2x minus 5 is equal to 5 raised to x plus 1. So if I want to have base 2, for example, logarithm base 2 of 2, this becomes 6x minus 15 is equal to logarithm base 2 of 5x plus 1. So here on the left, it becomes 6x minus 15. Here it becomes x plus 1 logarithm of 5 base 2. So let's combine those with x's. This one becomes logarithm of 5 base 2 plus 15. Therefore, x would then be equal to logarithm of 5 base 2 plus 15 all over 6 minus logarithm of 5 base 2. Okay? So that is it.